everyone, here is a cone problem. This is another type of related rates problem that you're going to need to know. It often comes up on the AP exam. It used to be free responses, now it's usually a multiple choice. But here's our problem we're going to do. We have a conical reservoir and we are pouring water into it at a rate of pi cubic feet per second. Now as soon as I hear something cubic, I'm immediately thinking volume. The reservoir has a radius of 6 feet across the top and a height of 12 feet. The thing I'm looking for is what is the rate that the depth of the water is increasing when the depth is currently 6 feet. So let's go ahead and label some stuff here. The volume going in is going in at a rate of pi cubic feet per second. The entire height, I'm going to call it big H, is 12. The entire radius, big R, is 6. I'm going to stop time whenever the little h, the little height, is 6. And I don't know what little r is. I don't know what the radius is at that moment. We're going to use ratios in a moment, though. Okay, so let's fill out our table here. We have big R, big H, little r, little h, and v. I think that's all of them, right? So we don't know what the volume is. That would be a subtle piece of information. We're going to hold off on finding this subtle piece of information. I'm going to put pi here. Pi does not go here. As soon as I hear the word rate, it immediately goes in the DDT table. Now, they told us that radius of the entire cone is 6, height of the entire cone is 12. Neither of these is changing with respect to time. So I could let time go on and on and on, and those are never going to change, so leave that as 0. I don't know what dr dt is, and I don't know what dh dt is. So now I have to figure out where does that question mark go? What is the ultimate thing that I'm looking for? And I want the rate that the depth of the water, which I'm calling height here. That's where my big question mark goes when the height is 6. So this is what I'm really after. Notice I don't know what R is, and I don't know what dr dt is. Now, the formula that I'm going to be looking for, or formula I'm going to be using, is volume of a cone, which is 1/3 pi r squared h. That's usually given on the AP exam. So let's see what happens if I try to do the derivative with respect to time. So I'm using implicit differentiation here. I'm going to pull out 1/3 pi and do product rule right here with r squared and h. So I'm going to do first times derivative of the second plus the derivative of the first times the second. This again is what I'm looking. Oh my God, what are you doing? This is what I'm looking for right here. And let's put a check mark by stuff that we know. I know dv dt, those are constants. I don't know r. I don't know r here. And I don't know dr dt. So these are question marks. But I know little h. The problem is I can't get anywhere in this problem because I have no idea what dr dt is. It's not even a subtle piece of information. I could never find it. So rather than saying, well, we can't solve it, let's just stop now. What we need to do is completely get rid of the variable r. And cone problems are solved using ratios. So we're going to do the ratio right now. I just wanted to show you why we even talk about ratios here. It's because we can't plug in and solve because we don't know what dr dt is. In your notes by this problem, I want you to write this note for yourself so you remember why we're even doing what we're about to do right now. We're going to rewrite this formula in terms of only one variable. You have to decide, is it going to be all r's or all h's? In this case, I want dh dt. I don't care about r or dr dt, so get rid of that one. I need to write a ratio here so I can use substitution and replace r. So that's the goal here. We want to replace r, get rid of it so that I don't even have to worry about dr dt. So the way people solve these related rates problems is they draw this. It's a 2D representation of this cone, and I have 6 and 12 here. And then for my little cone, I have R and H. Now we know what H is, but we don't want to put a number in for H. We want to keep it general. We're not going to plug in until the very end after we've done the derivative. So no plugging in for h or r, the little ones, until you've done a derivative. So let's write a proportion here. Big R is to little r as big H is to little h. So let's plug in. We have 6 over r equals 12 over h. Cross multiply, and we have 6h equals 12r. Remember, we want to replace r completely. So solve for r, and we get h over 2. I just did 6 over 2 is a half. H over 2 equals r. That is our proportion. And what we're going to do, let me move up here, is let's take this formula right here, and we are now going to rewrite it as h 1/3 pi times h over 2 squared times h. Notice there's only one variable here, there's no r, so when I do a derivative, I only have dh dt going on, which is what I want. There's no dr dt. So 1/3 pi, I'm going to go ahead and square this, h squared over 4 times h. Do not even try to think about doing a derivative until you've cleaned this up all the way. Actually, I'm doing too many steps here. There we go. 1/12 pi times h cubed. Yes. Okay, so this is my volume formula. This is what I'm going to do the derivative of. So now we're ready to do the derivative with respect to time, remember? And I'm going to do that over here. So dv dt equals 1/12 pi times 3h squared times dh dt. And before I plug in, I'm going to clean it up a little bit so that I don't have as much of a mess here. So pi over 4, h squared, dh dt. 1/12 times 3 is a fourth times pi is just pi over 4. So let's go ahead and plug in here. dv dt, the rate that the volume was going in was pi. I have pi over 4. I'm stopping time whenever h is 6. And dh dt is what I'm truly looking for. What I can do is cancel a pi on each side because it's there on both sides there. So now I have 1 equals 6 squared is 36 over 4 dh dt. And let's move up over here. Now I have 1 is equal to 36 divided by 4, which is 9. So now I have 1 equals 9 dh dt. Last step, remember we want dh dt alone, so divide by 9. And I got it. Let's put some units on this. This was feet, so it's 1/9 feet per second. So if I stop time, so I'm filling up this reservoir here. If I stop time at the moment when the height is 6 feet, the rate of change of the height is 1/9 feet per second. That's how fast it's increasing. All right, so make sure you have this whole problem written down. You're going to need this to refer back to. It's a very common problem, and it's the one that gives people the most trouble. This one and the theta problem. So make sure you watched the theta problem. Whoa, wrong one. Where am I? Make sure you watch the theta problem wherever it is in my notes here. And you watch this one for Monday whenever we practice this. All right, see you later.